Ya, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5, Fluid Lab, Section 4. And now I will explain about Lab 5, Pelton Wheel Turbine. So this is our group member, Wafi, Zikri, Abdul Rahman, me, Amir, and Daniel Shafiq. Okay, so my part is I will talk about the abstract. So in this experiment, we are introduced about the Pelton Wheel Turbine. The Pelton wind turbine is also known as impulse turbine, which there are two types of turbine, impulse and reaction turbine. This turbine will transform the energy in water into mechanical energy. The Pelton turbine gets the energy from kinetic energy of flowing water. Many turbines exist before Pelton design, but they are less efficient compared to Peltons. Water leaving the Pelton turbine wheels normally at high speed. So when the paddle wheels rotate at half of the speed of the water jet, the water will exceed the wheel slowly. The experiment will have two parts, which the first part is to find turbine efficiency, and the second part requires us to obtain the power curve. The rotational speed and torque data is provided for part 1. So for part 2, it's also provided with the rotational speed and power output. The pressure will be set on 0.2 bar and flow rate is 31.5 liter per minute. And then the result for the experiment is obtained and the graph is set.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zikri Hilmi bin Muhammad Daud, MA18143. I will present chapter 1 about the introduction. Okay, first I will tell about the background. Energy can take many different forms. Hydraulic energy is the energy that a fluid may provide. Kinetic, friction, and potential strain and thermal energy are all examples of the potential energy. Hydraulic energy is converted into the mechanical energy using fluid machinery. Turbines are used to generate mechanical energy from the hydraulic energy in this way. Turbines are classified into various categories based on their requirements. There are two types of turbines, impulse and reaction turbines. The water turbines transform the energy in the water into the mechanical energy. An impulse turbine, also known as a Pelton turbine or Pelton wheel, is a well-known type of the water turbine. Okay, next I will tell about problem statement. The Pelton wheel turbine works on the principle whereby the direction of the height velocity fluid in motion is changed to generate an impulse force causing the blades to spin the turbine. The kinetic energy of the fluid leaving the Pelton wheel will be reduced. The fluid's pressure head is converted into the velocity head prior to the entering the wheel with a nozzle. Okay, next is objective. Our objective is to determine the flow rate. Next, to determine the characteristic, and lastly to determine the power curve. Okay, for our scope is a bucket with an elliptical shape are connected to the periphery of spinning wheel in the Pelton wheel turbine. A water jet is guided tangentially to the vane pitch circled by one of two nozzles. The jet is divided and exists symmetrically on both sides of the vane due to the double outlet portion of the vanes. When the water jet enters the bucket, it generates momentum, which causes the bucket to spin. The shaft rotates in response to the rotation, generating mechanical energy. We can calculate the input energy, output energy, and efficiency of the turbine by measuring the discharge time, force, and Gauss pressure. The more output you have, the more effective you are. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdurrahman bin Bedu, matrix number MA19293. In this video, I will discuss about Chapter 2, Theory about Pelton Wheel Turbine. Okay, in 2.2, we will discuss about design of Pelton Wheel Turbine. As you can see in the slide, that is a sample of design of Pelton Wheel Turbine. Okay, next, move to the 2.3, parts and their function of Pelton wheel turbine. As you can see in the slide, I already list the parts of Pelton wheel turbine. First, we have nozzle and flow regulating arrangement. Second, we have braking jet. Third, we have runner and buckets. And last one, we have the casing. Okay, let's move to the next slide. For 2.4, we discuss about operation of Pelton wheel turbine. Next, in 2.5, we discuss about the formulas related to the Pelton turbine. And then at 2.6, we have history of Pelton turbine. And last one, we will discuss about the application, the theory of Pelton wheel turbine. For more information, I attach in the report. Thank you. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Syafiq bin Muhammad Rashid. Matric ID MA17018. So I will continue the presentation of Pelton wheel turbine with the method and procedure. So this is the lab number 5, which is the last one. So the method: power output from the force applied on buckets, which eventually generates torque that enable a wheel to rotate, was studied in this experiment. To determine the water's maximum revolution per minute, a tachometer was employed. So this is the apparatus that we are going to use in this experiment, but due to COVID, we were unable to enter the lab to run this experiment by hands-on. So the procedure: first one is the fast release connector is used to connect the equipment to the bench supply and to place it in the operating channel of the bench. Next, the tachometer is placed into the clip supplied and secured in place. The third one is the brake. The band brake assembly is elevated until it is free of the brake drum. Next, the bench pump is turned on and the bench control valve is completely open. The spear is recalibrated till the tachometer shows the maximum revolution per minute. The brake system is hoisted over the brake drum again and adjusted for a variety of reading on the spring balances. For each band brake setting, the spring balance and tachometer measurement are recorded. A time volume collection is used to determine the flow rate. The intake pressure gauge measurement is therefore recorded. The flow rate is controlled utilizing spare valve, and the experiment is repeated. This process is repeated until we obtain a set of data for several various flow rate. Every flow rate is represented by a graph. So the procedure in this experiment is it. I think that's all from my part. Thank you for your time.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fisher bin Fazilah, and I will be continuing for presenting of chapter 4, which is on result, graph, and also discussion. And this is the given data in the Google Classroom, which is the turbine characteristic curve. For the first one, we have the fully open constant at 0.2 bar with the constant Q at 30.9 flow rate. Then we have the second one is the power curve, pressure at 0.2 bar, and also Q at 18.75 L per minute. Then for the first graph that we obtained from the data given. This is the rotational speed versus moment of shaft, and based on the graph, we can look that the moment on the shaft decrease when the rotational speed increase. Okay. As for the second graph, this is the power output versus rotational speed. And from the graph given, we can see that the power output from the Pelton wheel will be decreased when the rotational speed increase. For the third graph, this figure shows the relationship between the power output and the rotational speed, but with different flow, which is we have two flow rate, which is 18.75 on the blue one and 30.9 on the orange one. We can see that the power output of Pelton wheel for the flow rate 30.9 is higher compared to the flow rate at 18.75. For the discussion, okay, the performance of the Pelton wheel should increase as the rotational speed of the wheel increase. This is because an increase in speed will increase power output before it reaches full efficiency before decreasing efficiency. Since the absolute velocity of the bucket is greater than the absolute velocity of the water, the decrease in performance is caused by the lower amount of water that can reach the buckets. Next, for our curve, the power output of Pelton wheel for the flow rate 30.9 is higher compared to the flow rate at 18.75. This is because the bucket speed exceeding that of the water jet. Since the turbine is now traveling faster than the water jet, it is unable to reach the bucket of the turbine, resulting zero power output. That will be all from me. I will pass on the conclusion to the next member. Thank you very much.
Okay, now I will talk about the conclusion. So basically, we learn about Pelton wheel turbine and its working principle, which is the direction of high velocity fluid in motion is changed to generate impulse force, which cause the blade to spin the turbine. And then the kinetic energy of fluid will leave the Pelton fluid, leaving the Pelton wheel will be reduced. At the same time, the pressure head is converted into velocity head prior to entering the wheel with a nozzle. So the objective for the experiment is to determine flow rate, the characteristic, and the power curve. And we learn and we obtain the data and perform the experiment well. So we also learn about how to set up the Pelton wheel turbine thanks to the technical stuff at UMP. So basically that is all. And then thank you.